we're going to find the slope and the tangent line to a parameterized curve at a point. So our example that we're leading off with is we're supposed to find the slope of the curve cosine t sine t at t equals pi over 4. Then we're going to find the equation of the tangent line at that point in terms of x and y, and then find it in terms of a parameterized line. So first, for the tangent line and slope in the form of x and y, we realize that t is what we want is pi over 4. So the xy coordinates there are square root of 2 over 2 and square root of 2 over 2. So this is our point. So we want the slope at that point, or the same thing, at t equals pi over 4. So might as well take the derivative. Dx dt is negative sine t, and dy dt is cosine t. So we realize that the slope is dy dx. The slope on the xy graph is dy dx, which happens to be equal to this, dy dt divided by dx dt, and so that's this. And so at t equal pi over 4, we have the slope is equal to that quotient, which is this, which comes out to be negative 1, and that line does have slope negative 1, as you can see there. Okay, so that's all there is to finding the slope. And then we have our point and our slope. So the point slope formula yields this line here, and it has a y-intercept of square root of 2, and sure enough, right up here it would have the square root of 2 over there, because this is 1. So that's perfect. Okay, now we're going to find how to do the parameterization equations for the tangent line. So that's a different process. First, to do that, we have to find out something about the velocity vector and something about what a vector is. So the velocity vector, which we put a little arrow over it, is the x component times a unit vector in the x direction, which is called I, and the y component of the velocity vector times a unit vector in the y direction, which we use j for that. So for example, where is the vector 2I minus 3j? So 2 units in the x direction, that gets you to here, minus 3 units in the y direction, gets you to here. So the resultant is this point right here, and that's where that vector is. The I vector is the unit vector on the x-axis from the origin to 1, and the j vector is in the y direction from 0 to 1. This vector notation is very useful. So for our example, x of t equals cosine t, y equals sine t, the circle. The velocity x component is your x prime, or dx dt. That was the minus sine t. And similarly, the y component of the velocity is your cosine t. So the velocity vector itself is minus sine t I plus cosine t j. That's your velocity vector. And what it does is it shows the direction the path is heading at that moment, at any t value, and the speed of the trace, the speed at which the point is moving on the path, is equal to the magnitude of that velocity vector. And the magnitude of a vector is the Pythagorean theorem. It's just the square root of the x coordinate of the velocity, or component of the velocity, squared plus the squared of the y component of the velocity. And so if you wanted to know the speed at any point t, value of the parameter, then you would just put in your vx squared plus vy squared. In this case it comes out to be 1 no matter what t is. So for this particular case, the path is uniformly traced out, and we've seen that in animations. So here's an important fact. The tangent line at a t value moment is in the direction of the velocity vector at that t value moment. And look at this little picture here. Here's your circle being traced out counterclockwise. So when you're at t equals pi over 4, this is where you are. Your velocity vector is headed out this way, and because that's negative sine for the x and cosine for the y, so your velocity vector was negative square root of 2 over 2 I plus square root of 2 over 2 j. So that heads you off in this direction right here, and that's the direction of the tangent line also, as you can see, because here's the tangent line there. So the parameterization for our line is going to involve, of course, your original equations. You take your derivatives, you evaluate it at pi over 4 if that's where you want your tangent line, and that comes out negative square root of 2 over 2 square root of 2 over 2. So the velocity vector is this, as we mentioned. So since the tangent line is in the same direction as the velocity vector, then the tangent line at pi over 4 is in the direction of this velocity vector. So all we have to do to parameterize the tangent line at t equals pi over 4 is start at the point cosine pi over 4, sine pi over 4 on the circle, which is this, and add on increments of the velocity vector to the point using a parameter. So here's the process. To parameterize a tangent line, add the x components, then add the y components using the parameter t, and here is your parameterization. X of s is square root of 2 over 2 plus negative square root of 2 over 2s, and y of s is square root of 2 over 2 plus square root of 2 over 2s. Notice that the original point that you have is here, square root of 2 over 2, square root of 2 over 2. That's this point right here. That's your starting point. And then the velocity vector, which is headed off over here, has negative square root of 2 over 2, square root of 2 over 2, and then increments of that. So to see how those increments work, we have a animation here. Alright, so here's our animation, and we realize that at s equals 0, the x value should be square root of 2 over 2 plus negative square root of 2 over 2 times 0, coming from this, and that is just square root of 2 over 2, which I put at decimal point 707, and the y value, according to the y equation, should be square root of 2 over 2 plus square root of 2 over 2 times 0, which is square root of 2, which is 0.707, and sure enough, when your s is 0 over here in the animation, the point there that you're at is square root of 2 over 2, comma, square root of 2 over 2. Then when we increase the s value, notice we start moving along the line, tracing out the line, tracing out that tangent line, and interestingly, I want to stop at about 1, right here at 1. Let's do 1 there. Then we're at this point. So over here at 1, we have square root of 2 over 2 plus negative square root of 2 over 2 times 1. That comes out 0. And the y value is square root of 2 over 2 plus square root of 2 over 2 times 1. And that is square root of 2, which is about 1.414. So 0, comma 1.414 should be where we're at. And that's exactly where we are at right here. 0, comma 1.414. So it's working. Then we can go on to see how the line would continue to be traced out as we increase the s parameter. Keep going, and we go on to infinity. Now, we could also go backwards with negative s values. So we'd be here at around 0, and then if we went into negative, it would trace backwards on the line and get the rest of it if you went to negative infinity. Stopping here at negative 1, negative 1 is s, square root of 2 over 2 plus square root of 2 over 2 negative times negative 1 comes out square root of 2, which is 1.414. Square root of 2 over 2 plus square root of 2 over 2 times negative 1 comes out 0, so we should be at the point square root of 2, 0, and that's exactly what it looks like we're at. So the parameterization of the tangent line is working.